The purpose of this lab is to analyze center of mass, projectile motion, and angular speed.
So for this lab, we found an irregular sized object. We used a wrench, and then we found its center of mass. We threw it and determined how long it took for it to travel. We plotted the center of mass and one of the tips for each frame of the video as we played it back, and then we figured out how many times it rotated and found its angular velocity.
The change in theta was 5 pi. T was 1. To get angular velocity, we divide 5 pi by 1, giving us 5 pi radians per second.
Lab was to analyze the center of mass of an irregular object. In this case, we used a wrench. We also analyzed its projectile motion as we threw it in the air and its angular speed.
So the equipment that we used in this lab was a wrench, a timer, tape, paper, markers, and a cap.
The purpose of this lab was to find a regular shaped object, and we used a wrench, and then we had to find a center of mass by balancing it on a finger, so we did it like this. And then we had to throw it in the air and recorded the time and determine how long it was in the air. We had to play back the video on the computer and determine both the center of mass and the tip, which we used the end here, and plot it for each frame, and then connect the dots and determine how many times the wrench rotated. This is our diagram. We had a thrower, and they threw the wrench, and it had tape on it to mark where it was in the video. We also had someone who timed the throw and someone who videoed it. They did 2.5 times, and it traveled for 1 second.
Now we're doing analysis. Change in theta is 2.5 rotations. T is 1. 2.5 rotations times 2 pi over 1 revolution will give us 5 radians. Pi. 5 pi radians.
So omega is the same thing as the change in theta over time. So we did 5 pi radians over 1 second to get an angular velocity of 5 pi radians per second.
The purpose of this lab is to analyze center of mass, projectile motion, and angular speed.
So for this lab, we found an irregular sized object. We used a wrench, and then we found its center of mass. We threw it and determined how long it took for it to travel. We plotted the center of mass and one of the tips for each frame of the video as we played it back, and then we figured out how many times it rotated and found its angular velocity.
The change in theta was 5 pi. T was 1. To get angular velocity, we divide 5 pi by 1, giving us 5 pi radians per second. We have 2 dotted lines, one of which is the center mass as it flies through the air in a shape of a parabola, the blue dots. The other is the tip of the wrench, which goes around the center of mass in a orbital way.
Errors to this lab, we had the wind, because the wind was really strong, so it could have kind of like added or subtracted from the number of rotations that we got. And then we also have air resistance because of our tape. It made like a bigger cross-sectional area, so maximized air resistance. And so to improve the lab, we need to not film when it's windy, because you know that'll probably fix a lot. And we have to make sure that we try to minimize that air resistance. We can do long distance passing.
Flower power. Now
Go.
Windy.
Go.
Yeah? You ready? Is he in it?
Yeah.
Hey babe, go away.
Yes! I mean no, but yes.
It's going.